So you're done with the quiz, correct? Let's start and finish this chapter. Chapter 7. Seven point three section, equilibrium. So N2 plus 3H2 gives 2NH3. Now if I write this equation with forward and backward arrow, it means there is equilibrium. Equilibrium means you will have reactant and product. This side is called reactant. This side is called product.
There's some stuff on like the homework now, like I don't know what it is. Yes.
Okay. So you have reactant and product. So is it here left hand side is reactant, right hand side is the product. So now if I ask you equilibrium means you will have some reactant, some product. You don't know how much it is. How do you know how much reactant is there, how much product is there? For that you need, the way you will know it once you know the value of K. If you determine the product concentration divided by reactant concentration, correct? If you do this, fortunately for you, you don't have to know this math. You get the value of K. Okay. So how do you do the product? So in this case, our product is NH3. So we'll write NH3 square. Why square? Because there are 2 in front of it. And then N2 and H2 cube. Why 3? Why I have written 3 here? Because it's 3 here. If it is 1, then you just write 1 or you don't show it, that's fine. So product over reactant raised to the appropriate powers. And how do you get the powers? From the stoichiometric coefficients. Correct? So this is the capital K expression. So in the quiz or in the exam, if it is asked how to write the capital K expression, you need to write it like this. But one thing you need to remember, if you have solids here or pure liquid like H2O liquid or solid, you will not include in the expression. So you will not include pure liquids and solids in capital K expression. So when you are writing this, if there is a solid or a liquid, you will not include. Let me explain with the help of an example. Go to that page 250. See 7.27. Can you see 7.27a? 7.27. Can you write the expression for capital K for 7.27? Page 250. 7.27. Or write it for. So in that, can you see that first one has carbon solid
So the following you don't write.
You don't write, you don't include in the equation. So if you write the expression, just write it the way you understand it and then apply it.
So it's still happening.
CO2 capital K equal to CO2 square, that's right. Divided by, no, CO square or CO2, you're right. Correct. And you will not include the carbon because it's a solid. This one.
Yeah, I need to write one. Or they'll just keep it together.
So this is the end product. Reactant has CO2, correct?
Oh, no, I didn't know if I split.
No.
Okay.
Correct, that's right. So, is it clear what is when the solid is not included in the expression? So if it is, the parenthesis says the physical state. So this says this ammonia is in gas state. S means it is in solid state. So if it is in solid state, you don't write it in capital K. Can you do B? Similarly, pure liquids. If it says L, you don't include in the expression. Pure liquids. That is the problem.
What do you do include the A? No.
AQ you include.
Okay. Do we include if it has like a negative power? Like if it OH negative, do I put OH negative?
Negative, just OH negative, the parenthesis. That's it.
Okay, I didn't know if we
And it's NH4 plus with positive. That you know. Plus means NH4 plus
Oh, okay. So do
NH4 ion. That's what it is. Right. That's so wait, which is on the this is product power. It should be on the Is this clear what is expected in this part? But then, what we do with this information, I'll explain to you. Huh? So, what we do with this information is, we use this information to do the math and determine the value of K, which you don't have to do. Correct? So, first for the reaction, we write this and then plug the numbers for each concentration and then find out the value of K. And if the value of K, correct? And if we find out the value of K is greater than 1, K is equal to 1, then we say reactant equal to product. If K is greater than 1, correct? If K is greater than 1, then we say product is more product. If K
This
is,
would have been great to know last night during the homework.
huh?
This would have been great to know last night during the homework.
Correct.
Everything.
If K is less than 1, it's more reactant. If K is greater than 1, it's more product. If K is less than 1. So once you do the math, you get the value of K. So from that you find out more product, more reactant, or more they are same. But in your case, you don't have to do that. You have a question when the K value is equal to 1, what you will do? When K value is greater than 1, when K value is less than 1. Is it clear? We will not ask you to do the math and do the, we will give you the K value. It's like this problem, like 7.36. Can you, 7.36 on next page, can you do that and tell me which is greater? 7.36 A and B.
So I told the K is less than
Correct. The first one says more product. Why? Because K is higher, greater than 1.
this one is going to be, if it's negative 3, then it's
Less than. Correct.
so it's going to be
More reactive. So, in this case, it's pretty straightforward. Like you have even you save a lot of work by you don't have to do the calculation. But in reality, when you take higher level class, you do the math and then you find out K is, in this case, K is given to you. So you need to know two things. One, how to write the expression, and then you need to say if it is greater than 1, less than 1, or equal to 1. What's the you have more reactant or more product, or they are equal. So that completes your 7.3 section. So only two things you need to know: how to write K expression and how to predict which is more. Now let's do the next section, 7.4, which is related to this concept.
Lee Chatelier's principle.
Lee Chatelier's principle.
Now let's use the same equation to
Now if we say that according to this, what happens, since K is a constant, if you add nitrogen, like let's assume in this
we are doing this reaction and we are adding, if you add nitrogen, in the other words, if you increase nitrogen, correct?
add nitrogen means you are increasing nitrogen. So remember what this principle says, if you increase this side, the reaction will go in the other side. It's like you are making this more. So where the reaction will go? This side. Correct? If you increase this side, the reaction will go on the other side. It's like a ball. Think about it. If you make it more here, correct? So the reaction will go in the ball will flow on this side, and the reaction will go on this side. Correct? If you increase this side, the reaction will go this side. Clear? So since if you add nitrogen, if you are adding nitrogen, means you are increasing nitrogen. So the reaction will go this side. So instead of saying reaction is going towards right, so what you say?
The reaction goes forward. There is one word called it goes towards forward or towards product or towards right. These three. This is your forward and this is backward.
So forward, towards product, towards right. It's the same thing. Correct? Any of the form the question can be asked.
But if you added some on the product side, you would say it goes backwards.
Yes.
Towards reactant or towards left.
Correct, exactly. So let's assume case 2. Add more NH3. Correct. So you are increasing. So what you will say, it will go backward, or you will say towards reactant, or towards left.
So is this clear? So what happens when you do on one side? So the reaction will go forward or backward based on what you do. So let's do some practice exercise so that we will check your understanding. Okay. So now 7.38. Read the question and do A. 7.38. Read the question and then do the first part, A part. Just do A. Huh?
Yeah, just do it next time. French fries.
First one divided towards reactant. Second one, what it says decrease. Decrease means that side is less. Correct? So decrease what?
The product side.
Decreasing CS2. Decreasing product means it will go towards product
Yes.
because that side is less. Correct? Is it clear? See, this side, so decreasing means you are making this less. So it will go that side.
It just confused me at first because it's like on the same side and when we did the example we just, but yeah, it makes sense.
Towards, so B, decreasing CS2 means it's going towards product. And last one is what? Towards react. Correct? Yes. Can you do 7.3 40? 7.40.
Okay.
ABC.
Or on. You want to do this? You want to do A, B, and C?
C. what's the answer for first? Can you tell the answer for ABC? A, you tell the A, B, and C. Yes.
Towards reactive,
For A towards reactant. Are you getting towards reactant? For B,
towards product,
C,
towards reactive.
towards reactant. Okay. So you got the concept, correct? These pattern principles. Now there is one more thing here.
See, sometimes in a chemical reaction, there are two types of heat is absorbed. Heat is absorbed. It's called, if the heat is absorbed, it's called exothermic reaction. Sorry, endothermic, sorry. If the heat is absorbed, it's called endothermic. And if heat is evolved, it's called exothermic.
If heat is absorbed, evolved or released.
Means instead of heat is released. It's a better word.
Now, if you see this reaction, can you tell me?
Is it an exothermic reaction or an endothermic reaction?
It's adding heat.
Are you adding or heat is given out?
Yeah.
Heat is exiting, correct? You are not adding. Adding means you add here. Heat is exiting, so heat is
Released. So this is an example of exothermic reaction, correct? So now, if you increase the temperature, where the reaction will go? See, increasing the temperature means you are making it this more, correct? Do you agree with this? So where the reaction will go? Towards reactant or towards product? Towards reactant, yes.
So the reason I mentioned this because in the quiz they may not give you heat here. They may say it's an exothermic reaction or endothermic reaction. So you know exothermic means
It's on the product.
product side. Endothermic means it is on the reactant side. Okay. So exothermic means it's on the product side, endothermic means it's on the reactant side. Then you could write down what happens here, cool down or increase. So that completes your 7.4 section. 7.3 and 4.
And then we
Region,
have one more section.
last section. So 7.3 and 7.4, do you have any questions?
Now the last section, that is 7.11. Now, let us tell you this reaction.
Correct. H2CO3 plus H2O gives HCO3 minus this one. This is nothing but carbonic acid bicarbonate buffer.
In our body. So carbonic acid, this is bicarbonate.
So this is the buffer
Buffer in our body.
So buffer in our body, carbonic acid, bicarbonate. Okay. So now let's assume in our body, because of some condition, if you increase the bicarbonate, where the reaction will go? Toward carbonic acid, correct? And if you make more carbonic acid, where the reaction will go? Towards this. Now, if you make more carbonic acid, that means the reaction will go towards product. So if you make more carbonic acid, the reaction will go towards product. Means what happens? You are making more and more acid. Then the condition is called acidosis. When you will have acidosis? When you increase carbonic acid. So if you increase carbonic acid, it will have acidosis.
Wait. So if you increase that,
See,
increase
if you increase H, correct. If you increase H2, the reaction will go forward. Correct? Do you agree with this? If it goes forward, you will have more H3O plus because it's going forward. Do you agree? So that condition is called as acidosis.
So in our body, we have certain amount of this and this all. But if you increase because of some reason, then what happens? We are making more acid, then the condition is called acidosis. Correct? So now the question comes when it happens. Like carbonic acid is formed by this reaction in our body. It is formed by reaction of
CO2 plus H2O gives H2CO3. CO2 plus H2O gives H2CO3. This reaction will give you carbonic acid.
So now this reaction will give you carbonic acid. So we know that we inhale CO2, correct? So CO2 dissolved in water gives you carbonic acid. And you know if you increase carbonic acid, what happens? You get acidosis. What's the condition? Example, if you hold your breath. Let's assume if you are going inside the swimming pool, you are holding your breath, correct? If you are holding your breath, what happens? Then you are increasing the CO2. Since you are increasing CO2, you are increasing the carbonic acid. Correct? If you increase this, it will go make more of this. Correct? In short, you will have more of carbonic acid. So if you hold your breath, you will have more carbonic acid, and we get acidosis. But acidosis, if it becomes severe, that's the reason if you hold it indefinitely, people die. Correct? So it's not possible for. But if you hold it for some amount of time, still will live. Correct? How our body prevents that acidosis? But our body pH should remain same. Correct? So what our kidneys do? Kidneys take out excess of H3O plus. So if you go inside the swimming pool, hold your breath, then what happens? Kidneys immediately start removing H3O plus, and they add bicarbonate. So there are two functions they do. They remove this, and they add more of this. So if they add more of this, what happens? Reaction can go backward, or it gets balanced. Is it clear? So in acidosis, what kidneys do?
What kidneys do in acidosis? Kidney remove H3O plus and they add HCO3 minus.
So this is the role kidney does when you hold your breath. Is it clear what is meant by acidosis? Acidosis means when you are producing more acid. When you are producing more acid. So in order to prevent acidosis, our kidneys plays a very important role. You know, if you drink plenty of water, your kidneys will be very healthy. That's what they say. The kidney, generally people get kidney stone and other things. It's because they don't drink enough warm water. If you drink enough good amount of warm water, you will not get kidney stones. Warm means like, it's not hot, lukewarm. Room temperature or little high.
So it's good to drink like room temp water.
Exactly, not the cold water. I think, huh?
I don't wonder.
So, that's what is very common in US. Actually, but it's best water to drink is warm water.
Weird.
And especially after eating pizza also. Because if you are eating that pizza, what happens when you eat warm water, all the cheese, grease things, it goes through your system rather than sticking to your digestive system.
I drink water like every meal I eat instead.
But it's good for, because kidneys are like a filtering system. So what they do, they remove H3O plus and add bicarbonate during acidosis. And exactly opposite happens when you hyperventilate. You know, when you hyperventilate, what you do? You breathe faster, correct? So when you breathe faster means you remove CO2, more CO2, correct? So if you remove more CO2, what the reaction will go?
Yeah.
Towards the reactant. So there will be less carbonic acid. If there is less carbonic acid, acid will be less. If acid will be less, what do you get? Alkalosis. Correct? Alkalosis means you are making less acid because acid is going back. So this is during, if you hold your breath, correct?
If you hold your breath, this is the condition what happens.
If you hold your breath, this is the condition. But now, if you hyperventilate,
Case 2. If you hyperventilate, what happens? H2CO3 will be less. So acid will be less. That condition is called alkalosis. So what kidneys do? They add H3O plus and remove bicarb.
they do the just the opposite. See, very nice diagram they have given on page 255, 245. 245. B, can you see that B 245? Alkalosis. So in alkalosis, what kidneys will do? In alkalosis, concentration of H3O is less. So kidneys will, what they will do? Generate H3O plus. Can you see that? Kidneys will add and they will remove the HCO3 minus. Is it clear? So they will add, they will release H3O plus, they remove HCO3 minus. So that actually what I discussed is A and B in that page. Acidosis and alkalosis, that you need to be familiar with. Page 245. So that completes the chapter, that completes everything that you need to know for the exam.
I understand this a lot better.
So you will get 100% in the exam.
Okay.
So that page 245A is condition for holding your breath, B is the condition for hyperventilation. So, ready for the lab? Or do you have any questions on anything? See, I'll tell you what you need to do, just for your planning, like how you plan your studies.